All right, hello, absent students. Let's do this practice exam. I'm not going to do the first limit. I'm not interested that much in those on the exam, so we're not going to do it. I want to go right to number 2, okay? I'm going to copy and paste it to my other page so we can do the work right by the problem, and then we will give it a shot. Are you willing to be called on, or do you want me to do it myself? You're always free to say pass, okay? You're always free to say pass. So the question is, find a vector function that represents the curve of intersection of the two surfaces. Cylinder, that thing's parallel to the z-axis, right? Just imagine it. It's got a radius of 4 and it's up and down, right? And then the surface z equals x times y. I can't visualize that one as well without a graphing utility, but so two surfaces, and I think we can do it. So Josh Sorkin, what do you think for parametrization? What could we let x be and what could we let y be? Let x be 4 and y be 0. That would only be a point, so that wouldn't introduce a parametric. How do we do a circle? How do we do the unit circle? Sine and cosine. So we're going to do that for this. So let's let x be 4 cosine t and y be 4 sine t. Okay? And then therefore, we should really let t vary between 0 and 2 pi to get ourselves all the way around the cylinder. And let's go visualize this too on the plot 3D once we have it built to just see if it really works. And then so z is just a subbing in of those two things. So z would be 4 cosine t times 4 sine t, or 16 cosine t sine t. Wait, that's an identity, isn't it? 8 sine 2t, right? No need to know those for the test, okay? It's just a fun fact. All right, so here's z. So let's go look at that parametrically and make sure it works okay. And you know what? Let's do it on the calculator so you guys actually have to show you that you too can test it if you want when you're on an exam. Okay, so remember the 3D graphing is found under View and 3D Graphing. Unfortunately, I'm not going to be able to show you the cylinder because there's no z, and these are required to have z in it. I could parameterize it, but you guys might get a little confused by this, so track with me on this. If we go x is 4 cosine t, y is 4 sine t, and z is u, I build it so that t goes 0 to 2 pi and u goes from like -4 to 4. This should give us the curve of the surface we want. I failed. What did I do wrong, you guys? Well, u is the parameter that's going to make the cylinder go up and down. So it's like saying, when z is 1, that gets us a circle. Your degrees. Oh, thank you. That was an easy fix, eh?
I looked at it for a second. I'm like, what is wrong?
There you go. Okay, so there's our cylinder. So that's the only way to do that if you don't have a more powerful tool. You have to do it parametrically. All right, now let's go back and do the other function. What was it? Z equals x times y? Okay, so what does that look like? All right. Yeah, we need to get some color going on here. Color, custom plot color. I don't know what that means. You think it's fill color? Fill color red? Yes. Very nice. And to parameterize this, I'm going to need to zoom out, don't I? So I can see more of it. So let's go out to -10 to 10, -10 to 10. There we go. Now when I actually put my curve on there, I should be able to see most of it. Okay, so let's go back to parametric and do, what was it? Remind me, 4 cosine t, 4 sine t, and then 8 sine 2t. Okay, so let's make sure our parameters are set up. They are, and we might not even be able to see the curve, to be honest. Can you sort of see it?
Yeah.
You can sort of see it. the cylinder doesn't go high enough to really show where it's intersecting, but at least you get a sense that, yeah, we didn't totally screw it up. Good? Yeah. I graphed the cylinder with parametrics. We don't technically yet know how to do this using two different parameters. So you can either say, hey, I just learned it, because you did sort of just learn it. You do 4 cosine t, and then let this be a different parameter. Or you can just say, I know what a cylinder looks like. It's going to be straight up and down. Okay. You could, by the way, you could mess with it and go like this. You could say, put the u here, and then put the other one 4 cosine t down here, and you would see a cylinder then going in the other direction. So, I don't know. Good stuff to know. Any questions on this? As far as a test, let me give you a couple reminders. If you see circular motion, I recommend parameterizing like that. If you see non-circular, I recommend letting x be t, or maybe y be t, and kind of fiddling around with it to see through substitution what works.
You made it 4 cosine 4 sine because
That's the radius, yep, radius of 4. Anything else? Yeah.
Do we know like law of sines and stuff?
No, none of that's needed, no. Okay, let's do 2. No, let's do 3. That was 2. Oh, really?
Yeah.
I did not know that. Windows Shift S. Okay. All right. So what does this say? Find a vector function that represents the curve of intersection. Maybe this isn't so interesting. Same thing, or is it though? If x is t.
It's the same style of question.
I don't know if it is though.
Well, define the vector function that represents the curve of the intersection of the two surfaces.
But it's not circular motion.
But the way that it's laid out.
Yeah, then you're gonna have to substitute stop.
Well,
Okay, let's play with this because this is not exactly the same. My instinct says to let y be t, therefore z is 2 plus t. And then with those two things, I can say 2 plus t equals root x squared plus t squared. Square both sides. And then x squared equals 2 plus t squared minus t squared. So x is the square root of that. Is this the best way to do this? Is there any?
Z is always greater than 0, right?
Yes, z is always greater than 0.
So we have a 3b to limit t
isn't this a semicircle? This
since
trace element is the
like
axis.
t can be any number right now.
You mean limit z here?
Right.
Because if z must be greater than 0, then t has to be
Greater than -2.
greater than -2. Yeah.
Well, does it not? Don't we just
It shouldn't.
y equals z equals?
Yeah, it shouldn't matter because this is tracing a semicircle,
Yeah.
right? So it will always be in the positive.
Mm-hmm.
So it shouldn't make a difference.
Okay, I would say this works. I don't know if it's the most elegant way to do it. So let's check the solutions and see what they say. Chapter 13, practice exam solutions. Here they are. Okay, 1 we didn't care about, 2 we got right, and 3, that's different, huh? They let x be t. Okay. Now, why is that better? If x is t, then how do we get y? You see what I'm asking?
Oh, I see.
If we let x be t, then
Well, you can set that 2 equal. Like
Yeah.
x plus y squared equals 2 plus y.
oh, sure. And then say this is root t squared plus y squared equals 2 plus y. Okay, let's play with that and see if we get to the same place. Yep, it works. I don't know if that's better, though. I'm curious if visually they both work. Like, I'm curious if we parameterize with this, I mean, we should, right? We should get the same curve as if we parameterize with this. Let's try it. Like half the class, no, I'll just do them both up here. Never mind. Let's use CalcPlot 3D.
Why shouldn't we say that
It shouldn't matter. It's physical.
the C is
Okay, so let's look at this curve. Okay, that's weird.
Do you mind graphing the original function?
Yeah, let's graph the original surfaces. Good point. The first one was a regular function, wasn't it? Square root of x squared plus y squared. So there's our cone.
Yeah, you see it doesn't see.
Yeah, cool. Okay, and then what was the other one? Thanks. Z equals 2 plus y. Oh, we did it. That's pretty neat.
Oh,
So,
wait, why is there that? Oh, that circle was you dragging.
yeah. Now, what about though? I guess our parameterization has the effect of cutting off the curve right there. So, right, we only allow positive x's. So technically, we should put a whole nother. I should like copy this thing and have it be also negative square root of this. That would then take us the whole way over. Don't worry about that. If you can parameterize it, I'm not going to worry about you having the right t-bounds on it or anything. Okay? Questions there? All right. Let's try number 4. Do we? Okay, guys, you do this one on your own. I think you can handle this. Freeze the screen. Stop the recording. All right, recording is back. You need to do each component's derivative. So the derivative of the x component, not derivative, sorry, antiderivative, okay, evaluates to 1/2. I chose to do this just to practice my skills, okay? You don't have to do integration by parts on the test, okay? You will have a calculator. The answer ends up being -2/π². And then the last case is not so bad. That ends up being 2/π. Okay? So at the end of the day, here is, oops, I made a little mistake there. This should be 2/π. That's our answer. Okay? What is that doing for us? It's really just testing your integration skill, because what would it mean to integrate position from 0 to 1? It doesn't mean anything. No, that would be velocity. You're integrating velocity, right? So it doesn't mean anything from a physics perspective. Okay? Okay. So here we go. All right, so helix intersects the curve. What do we need to do to find angle of intersection? Ultimately, yes, but we need 2 vectors first.
You need the tangent.
The tangent vectors, right?
The point of intersection.
Yeah. So from this point, which is when t equals what, by the way? 0, does that work? So when t equals 0, we need r1 prime of 0. So we'll find the vector function for that. And we need r2 prime of 0. And we'll find the vector function of that. I do not like the rainbow pen. It's driving me crazy. It just looks weird. Okay, so this is negative sine t, cosine t, and 0. Nope, not 0, 1. And then 1, 2t, and 3t squared. Okay, evaluate this at 0. R1 prime at 0 is, 0, 1, 1, right? And R2 prime at 0 is 1, 0, 0. Okay, angle between them.
You dot them, divide by the magnitude, multiply.
But dotting them is makes us finish it, doesn't it? Because dotting them is 0. right? So cosine theta is 0 over whatever. And so theta must be 90, yeah. Cool. Yes?
For the rainbow R primes, you wrote R prime of 0 instead of R prime of 2.
Right. I should have not put 0 in there yet. You're right. This should be t's. Thank you. Okay, that could be fair on a test. That'd be good, right? Because it involves a little bit of derivative and evaluating a derivative, and then a little bit of material from the past where we're doing angle between vectors. So I like that question. Oh yeah, sorry. Here's the definition. Cosine theta equals u dot v over magnitude u magnitude v. That's what we're using. Okay. All right, back to the practice test. Is 8 worth doing? No. I don't think so. Is 9 worth doing? The derivative of the dot product? It's all simple, right? I mean, you're gonna first evaluate the dot product and then do the derivative, or you can use the product rule if you want. Okay. 10, I never talked about Simpson's rule. We're not gonna do that. Let's do 11. Okay, so 11 says find the unit tangent vector for this curve. Oh yeah, I forgot to call on people. That's right. Shut up, Sufyan. Oh, that's recorded too. Why am I so foolish to be recording class ever? Okay, yeah, let's call on people. This is calculus you all can do. Raf, it's to you. Give me R prime.
T cubed. T squared.
1. Good.
Oh, yeah.
And let's do magnitude then. Raf, keep going.
Okay, so t to the 6th plus t to the 4th plus 1.
Good. Anything we can do to that to like clean it up? Not really, right? I don't think so. So big T then is found by doing t to the 3rd over, can I just say all that junk? And then t to the 2nd over blah, 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 and 1 over blah, blah, blah. Right? And this is, that's the junk.
Can we write junk?
Sure. I don't care. If you like abbreviate it for yourself and to avoid some writing, I don't mind.
Equals
Yeah.
by jump.
Yeah, junk. Okay? No profanity on the test, okay? Okay. I almost again, I'm being recorded. Okay.
I'm gonna have like another censor button.
Yes. We need to beat myself out, right? Now, you all know the commands on the calculator? Yes. So just to review, first we define a function. Define R of t to be a 3 by 1 vector that has 1/4 t to the 4th, 1/3 t to the 3rd, and was it t at the bottom? That's 4. Good? Is that right? So now to find unit tangent, we would do the derivative of R of t over the magnitude of the derivative of R of t. Let's see what their answer looks like. Oh, just like ours. They didn't do any more simplifying.
Is there a difference between the like writing out define and using the like equal sign colon?
No difference. Yeah, it's easier to do equal sign colon, right? R of t colon equals same thing. Yeah.
Do you have a trick to because when I tried using defining R of t and then doing that, my calculator died. It just took too long.
Oh, really?
Do you have a trick to make it be able to compute it?
Don't know. Sorry.
If it does the equal thing,
I know how to cancel it, but I'm just
Okay, let's do 12. Can you do 12 alone, please?
on the curvature, R prime t plus R
Cubed. Find me curvature at the point -1, -1.
Oh, wait, no, it's a function.
Here we go. Okay, so just as a note, think about how we moved from dt ds to then the magnitude of big T prime over magnitude of R prime of T to finally the useful definition of curvature, right? Magnitude of R prime cross R double prime all over magnitude of R double prime. Oh, sorry, R single prime of T cubed. And don't ask me why I forgot the T on the R prime. Pretend it's there. R prime of T. So would I ask you to derive the whole thing? No, that's not fair. Because I know you just memorize it anyway and try and, or whatever. But if I asked you about a step along the way, if I maybe outlined a step and then said, why is this step legal? That would be kind of a cool question, right? Like, I write down a few steps of the proof and I just say, can you justify why these steps are okay? That would be something more interesting to ask. Okay? Oh, sorry. I got it.
Are we going to
The formula sheet. That's what you're allowed. Okay? All right. Are there any other questions on this practice exam that are worth us looking at? Find an expression for that. That's just going to be a bunch of product rule. I mean, not product rule. Yeah, product rule. What about 16? At what point is the normal plane? Ooh, that's kind of cool. Shoot, but it's 312. That's okay. All right. So the exam's not till Friday. So we're not going to review for 2 more days, but we'll review a little more. So I'll do a little more review and then I'll start something new before the exam. Okay? So for your homework tonight,